You're watching Rails for Zombies, and this is level 2, where we're going to be talking about models, the lifeblood of your application. You've already been working with models, but you don't even know it yet. See, models are how we communicate with our data store in Rails, the lifeblood of our application. Here's a customer's browser, and it's about to hit our Rails application. When it does, it's going to encounter 4 components, as you see here. We're going to be learning about those components in the next 4 levels, starting with models, which are about there. In the previous level, when we called tweet find 3, and it went to the database to find the tweets table, well, it was actually able to do this only because there was a model that was called tweet. This is a file that resides in the app models directory. Notice it's singular, lowercase, tweet.rb. Inside this file, this is what we find. Class tweet inherits from active record base. When we write capital tweet anywhere in our Rails application, it means we're referencing this tweet model. Since this tweet model inherits from active record base, this is what maps this class to the table which has the lowercase plural name tweets. So when we call find3 on our tweet class, and the type of class that it is a model, it goes looking inside of our tweets table. What gets returned is an instance of this class, which has the values for tweet with the ID of 3. This is what gets set in our t variable. What would happen if we created a new tweet and immediately saved it without setting any values? Well, it turns out it would still create a new tweet with a blank status and a blank zombie, which is not what we want. We don't want that in our database. So how would we fix this? First of all, if we wanted to make sure status was never blank, we could go back into our model class and specify validates presence of status. That means our model is going to validate that we do have a status, and if it doesn't, it's not going to allow us to save it. So if we go to the command line and we create a new tweet now and call t.save, it's going to return false. If we didn't have this validation, it would return true, meaning it was successfully saved to the database. To figure out what went wrong, we can run t.errors.messages, and it's going to return a hash with values that show us what went wrong. To print out just this error message, we could access the string inside of this hash by writing t.errors status and specifying we want the error in the 0 position because it is an array. See those brackets? Rails comes with a bunch of model validations right out of the box. Besides validates presence of, we have validates numericality of to make sure something is a number. We can say validates uniqueness of to make sure something is unique. We have validates confirmation of if we have 2 fields like a password that need to be equal. We have validates acceptance of if there's, say, a checkbox they need to check like they read the terms of service. There's validates length of to make sure that something they entered is longer than maybe 3 characters. There's validates format of if we want to specify a regular expression. For example, if we want to make sure their email is valid. There's validates inclusion of if we want to make sure that a field like age is in between 2 values. And lastly, validates exclusion of if we want to make sure a value is not included in what the user entered. Validations have another easier syntax to use. We can write validates and then specify the attribute we want to set some validations on, and then specify what we want to validate about it. For example, presence true. Then if we wanted to, we could write another line, validate status length 3. But as you might imagine, there's a better way to write this. We could combine these two to simply write validate status, presence true, length 3. All in one line. Now I said all in one line, but you might be saying, hey, that's 3 lines. Well, that's because Ruby knows statements like this that sort of end with a comma at the end. It's going to look at this and run it all as a single line. there's going to be other places in this tutorial where you're going to see things on multiple lines, but Ruby is going to interpret it as a single line. Just as you saw on the previous slide, there's a bunch of different validations that we could use with this new syntax. Most people who are programming Rails apps are using some form of relational database, meaning that you've got multiple database tables and they have relationships with each other. So let's figure out how to define a relationship using Ruby on Rails. Currently in our tweets table, we're storing the name of the zombie that did each of the tweets, but we want to add some additional attributes to the zombies, like what graveyard they're from, in which case it might be nice and eliminate duplication if we had a zombies table. So let's change our tweets table to have a zombie ID column referring to which zombie that tweet belongs to. You'll notice here that tweet 1 and 4 belong to the same zombie ID. Now here comes our zombies table. We're now specifying the zombie name and the graveyard it belongs to. And you'll notice that the ID on this table refers to the zombie ID up in the tweets table. The only thing that's left for us to do is to figure out some way to tell our Rails application that this relationship exists. We need to map these two models together. In our case, we want to specify the relationship in both directions. So we need to tell our Rails application what relationship a zombie has with a tweet and what relationship a tweet has with the zombie. So first, as you can see with the table here, how do we express that a zombie has many tweets? To do that, we go into the zombie model, which we probably created ourselves when we created our zombie table, and specify has many tweets. Notice that tweets here is lowercase and plural. That's all there is to it. Now let's switch the tables around and figure out the other side of the relationship. So if we had to articulate this relationship, we might say that a tweet belongs to a zombie. So now in our model, we need to express this relationship. All we have to do is write belongs to zombie. And that's all there is to it. But notice here, this is singular because a tweet can only belong to one zombie. Now let's go ahead and run some code. First, we're going to fetch the zombie with ID of 1 and set that equal to ash. You'll notice here what gets returned, that's actually the instance of our zombie class with the values of zombie ash. Now let's create a tweet for zombie ash. We're going to create a tweet with status, your eyelids taste like bacon. And the second parameter here in our hash is going to be zombie ash. So we're actually sending in the zombie object, and Rails is going to take care of all the mapping for us. You'll notice here what gets returned is our new tweet that has an ID of 5. It created the ID for us, the proper status, and it has zombie ID 1, which of course is Ash's ID. Now if we call ash.tweets.count, it's going to return that Ash has 3 tweets now. And now if we call ash.tweets, which is using the has many association, it's going to return an array with 3 instances of tweets which belong to Ash. Now if we look back in our database, we would see that it created a new row for us for Ash's new tweet. One more thing. Now if we fetch this new tweet out of the database, we could call t.zombie. What this would return is an instance of a zombie, an instance of Ash. We could even call t.zombie.name, which will give us back the zombie's name, in this case, Ash. Now it's time for you to practice creating some models of your own, and I'll see you in level 3.